Yes, good evening, Adesha. What we were discussing in last class?
Sir, you said you will start integration.
Integration.
Okay, let's get started with that. Just a minute. Yes, so we'll go with the trigonometry. Can you see the screen, Adesha?
Yes, sir, it's visible.
Yes. Okay. So first of all, what you have learned in differentiation, like we have learned, parametric form, different forms of differentiation. If two functions given or function to the power of function given, how to differentiate that we have learned, and we have solved related questions as well, right? So here basically we'll be talking about two types of integrals. One is indefinite integral and another one is definite integral. So integrals. So we'll be having two parts in this topic. So in this chapter, we'll be having two parts. One is indefinite integrals, and the another one is definite integral. All right, indefinite integral, definite integral. So basically, indefinite integral, what we will be learning in definite integration will be what we will be learning. Okay.
Yes, sir.
Okay. So let me give you, first of all, we'll be talking about indefinite integration. Then we'll talk about definite integration. Okay. Let's start with indefinite integration. Indefinite integrals. All right. Yes. One second. Yeah. So basically, let's talk about first of all, like indefinite integrals and definite integrals. I said, what do you mean by integrals? First of all, so basically the integrals is nothing but the reverse process of the derivative. What is that? A reverse process of the derivative is called integral. Okay, it's called as integration. Basically, look at this. So let me just talk about this indefinite somewhat later. Let's talk about, so first of all, look at what happens. So now d by dx of sine x, what is that? Cos x, right? So d by dx of sine x is cos x. If I integrate this function again, I must get my answer as sine x. Getting my point?
Yes,
You
sir.
understand? If I integrate this, I must get answer as what? Sine x. So that is the reverse process. See, in integration, in different differentiation, what we do? We differentiate this and we write this answer. In integration, we'll integrate this so that I need to get this. Is it clear?
Yes, sir.
So, and you could say that, for example, look at it here, and an integral of cos x dx is equal to sin x actually. Sin x plus c will write. What is the meaning of plus c? I'll tell you.
So
All right.
plus C is constant.
Yeah, plus c is constant. Why it is? I'll tell you. Don't worry. See, first of all, let us talk about the indefinite integrations, a definition. So we'll talk about. I just you hope you got an idea what is that. So indefinite integration. Indefinite integrals is nothing but an integral. An integral. You just simultaneously write an integral which is not having any upper and lower limit. Okay, upper and lower limit is nothing but this is how I denote integrals. Okay, this is the way of denoting integral. This is my lower limit, this upper limit. Okay, you won't be having any kind of upper and lower limit in indefinite integrals. In definite integrals, you will be having like this: upper limit as b, lower limit as a here. But in indefinite, this is indefinite integral. Okay, this is indefinite. This is definite. In definite integrals, we will be having upper and lower limit. In indefinite integrals, we would not be having any kind of limits over here. But mathematically, how I represent this? Mathematically, how I represent this? Look at this. Mathematically, if f of x is any antiderivative. What do you mean by antiderivative? Antiderivative of
Reverse
f
of the derivation.
yeah, reverse of the derivative. Derivative of some small f of x, then the antiderivative of f of x is called as is simply called an indefinite integral. Basically indefinite. You can say antiderivative of a function is what? Integral. Or reverse process of derivative is what? Integral. You can define in any way actually. In either ways you can define that. So basically look at this here. For suppose d by dx of some f of x is equal to beta. D by dx of some f of x is equal, let's say that, okay, small f of x. Okay, for suppose. Okay, now if I integrate this, small f of x dx, then I must get what? This f of x, capital F of x plus c. This is a general, way of indicating them. This is how we denote the integrals. What is this? Integral. This is integral symbol. All right. This is a derivative of the symbol. Now, what do you mean? What do you mean by this? Actually, this is a symbol of integral. This we are integrating the function with respect to what? Dx. All right. Without without fail, you have to write the dx. Actually, getting my point? You understand? Yeah. Now,
Yes, sir.
I'll just give you the data. What is what now? Okay. First of all, what are the symbols we have here? symbols. And what is the meaning of that? I'll give you. Don't worry. Everything you'll understand in neatest manner. So very important topic. You have to concentrate very neatly. Every day you have to focus and practice every day. Okay. So now, just now I told you that integral of, how do you read this? Integral of f of x dx is nothing but, what is the meaning of this? Integral of the function called f with respect to what? X. How do you read this as? What is the meaning of this? Integral of the function called f
with
with
respect
respect to
x.
x. Okay? Yes. Now, sir, what do you mean by this f of x? ये खाली f of x को क्या बोलता? What do you mean by this f of x? This is my integrand. What is this? Integrand. Integrand. Or else you simply say, simply what is, where f of x is equal to what? Integrand. ठीक है? हाँ. What is this x here? What is x here? X is what? Variable of that integration. What is that, beta? Variable of
Integration.
Variable of integration. All right. Everything neat. All right. Now see here. So if I differentiate this function, beta, look at it here. Look at this. I just wrote differentiate, f dash of x. So differentiate it, I must get what? Again my f of x. Getting my point? Why? Because integration of this is this, means a derivative of this should be this, right? Isn't it? As I told you, beta, integration is what? Antiderivative process, right? Antiderivative process.
Yes,
so
sir.
integral of this function is this, then derivative of this guy has to be this, isn't it?
Yes, sir.
Derivative of this function has to be this. So we can say that capital F dash of x, capital F dash of x is equal to small f of x. Okay. Any doubts?
No, sir.
Yeah. So now, so basically I'm telling you, right, what is integral? Integral, what do you mean by integral here? Integral is nothing but what? I mean, integration. I'm saying integration. Integration is nothing but process of finding the integral. Process of finding the integral. Integration. The topic name is integrals, but we call it as integration simply. Integration is nothing but process of, what is that? Process of finding the integrals. Okay. Process of finding the integrals. Integral means what? I just told you. Look at it here. Integral means what? Reverse process of the derivative. You can say like that. Antiderivative of f is, then antiderivative of x is called as indefinite integral. Okay? Understood my point? Integration is the process of finding those integrals is integration. Okay? Understood my point? Now
Yes,
let's
sir.
talk about C. What is C? That constant. What do you mean by constant? What do you mean by constant of integration? Constant of that particular integration. Constant क्या होता है एक बार देख लेंगे. ठीक है? हाँ. Basically any real number called C would be considered as what, beta? Constant function. What is that? Constant function. ठीक है? Any doubts? Any doubts? So what is
No,
what?
sir.
I'll whenever I explain you the questions, I'll explain you what is what. Don't worry about that at all. Okay. Now I'm just telling you what are the meanings, what are the terminologies we'll be talking about in the integrals lesson. Okay. And write a note here. Write a note. Integrals, or you say anti-derivatives of the functions are not unique. Actually, they are not unique. Okay. You say that this is one point. There exist infinitely many anti-derivatives. antiderivatives of each of certain functions. Okay, by choosing what? It can be obtained by choosing C, that particular constant, arbitrarily from the set of real number family. Okay. Now I'll tell you. Look at this here. So first of all, let me talk about a couple of properties. Then property before giving you before getting to the properties, I'll just give an example. Okay, you can simply just skip this as well, no problem. But there exists infinitely many antiderivatives of each certain functions with respect to that particular uh, arbitrary constant called C in any in real number family. There exists what infinitely many antiderivatives of each certain function of that arbitrary constant called C from real number family of C from real number, you can say. All right. Look at this. First of all,
Yes.
1 second. Right. So we have spoken about the general value. What is the general value? Where is that? Yes, there is a general value. If I integrate any function called f of x with respect to x, then I would be getting capital F of x plus C. I just look at this here. As I told you, I'll tell you again. If I have something like this, look at this here. D by dx of capital F of x dx is equal to d by dx of capital F of x is equal to, let's say, small f of x. Okay, small f of x. Now, if I integrate the small f of x with respect to the function, with respect to the variable called x, then what I need to get? I need to get capital F of x plus C. I told. As I told, what is this? This is integral sign actually. Okay, this is integral sign. And what is this f of x? Integrand. I told you. Am I correct? Integrand. What is this? Constant of integration. Constant of integration. And what is this? X is called as our variable of integration with respect to x. Okay. All right. So now look at this. The meaning, the example, if I give you here is, see, if for suppose, as I told you, beta, look at this, d by dx of some x square is equal to, or else I'll just, you don't know the formula, right? So let me give d by dx of some, sine x is equal to cos x, right? Now you have to integrate this. Integral of cos x with respect to dx is equal to what? You have to get sin x.
Sin x
Sin x plus c. Okay.
plus C.
This is a basic operation, right? Now, see what we have spoken about. This is what notation. What is this? Notation of the integration. Notation. I would say notation, right? So first of all, let me talk about the basic and important formula of the integrals. What is the basic formula? Basic formula of an integration. I'm just teaching you what is required for your syllabus. I'm not going anything more than that, which makes unnecessary confusion to you. Right? Basic formula for integration. Sir, what is the basic formula? For the basic, what was the basic formula for the differentiation? D by dx of x to the power of n was n into x to the power of n minus 1, right? Isn't it? D by dx of x square means what? N into x to the power of n minus 1. So 2x. That is how we used to write. Correct? This was the process in differentiation. Now, similarly, look at this here. You have a formula called integral of any function x to the power of n. Look at this integral of x to the power of n dx is equal to x to the power of n plus 1
n
by
plus 1 by n plus 1.
n plus 1 plus c. All right, this is a basic formula. Okay, this is a basic formula. Based on this only, we'll be talking about, every question, everywhere we'll be talking about this, right? So basically what happens here is, in differentiation, what happens? One power used to be less actually. See here we are reducing a power. Understand my point? Here we are adding, that's it. Check. Here reducing the power, here adding the power. That is why I told you the reverse process of the differentiation is integration, right? Reverse process of the derivative or differentiation, you say, is what? Integration. So there I was subtracting the power. Now I was subtracting that. I'm adding here. Very simple. Is it clear? Is it clear?
Clear, sir.
We will see couple of examples and I'll show it to you now. Okay. We'll see and we'll observe the things. Now,
So based on this formula only.
based on this formula only, I'll show it to you what is what now. For suppose, look at this here. D by dxl. First of all, let me talk. The left side I'll be talking about differentiation. Right side I'll be talking about integration. Okay. So or else first left side I'll talk about integration. Anything is fine. So integral of 1 into dx. I'm integrating that 1 with respect to what? The function called x. With respect to the variable called x. So what is the answer is what is the answer is going to be now? Answer is going to be simple x. Simple x plus c. Simple x plus c. Sir, what is this c actually? Why we are getting this c? I'll tell you. Else, first of all, let me talk about the different. Let me give a simple example. I'll give you. First of all, any function you take, beta. For suppose, for example, I'm telling you a function called. I'm just giving you a function called y is equal x square. Okay. So now I'm differentiating this. How do you differentiate? Dy by dx. The meaning of this is differentiating the given function with respect to x. That is 2x. Cool, isn't it? 2x, right? Yes. So now similarly, if I integrate that 2x, if I integrate this 2x, I must get x square with respect to what? Integrating
Dx.
answer 2x with respect to dx. What I have to get now? Where 2 is a constant, beta. 2 is a constant. Whenever you have constant, you just throw it outside. What you left with now? Integral x into dx or not? Tell me. Isn't it? Yes or no?
Yes, sir.
So 2 into this is x to the power of 1 or not? Now x to the power of n formula, what I told here, x to the power of n
Plus 1 by n plus 1.
Now these two will get cancelled. What you left with here?
X square.
X square. I won't write plus c.
X
I'll
square
just
plus c.
plus. I don't write plus c now for a while. I'll tell you why it is. X square you got. Now are you getting the same answer or not? Check. Yes. Yes. If I differentiate this, I was getting 2x. Differentiation of y is equal to this 2x. And integration of this 2x has to be what? X square. Am I getting or not? Yes. I'm getting that. Clear? Yes. Now, for suppose, I'll just give you a simple example. Look at it here. Derivative of d by dx of x square plus 9, you say. What's the answer of this, beta? D by dx of this function is simply 2x. Am I correct?
2x.
Isn't
Yes,
it?
sir.
Yeah. So now d by dx, I'll give one more example. Look at it. D by dx of x square is what now? Simple x square is also 2x.
2x.
Okay. d by dx of x square plus 2 is also what? 2x.
2x.
All right. Why? Because d by dx of constant is 0, right? Isn't it? So what I can conclude
Yes,
here?
sir.
So d by dx of x square, any constant plus c is equal to what? Always 2x. Isn't it? So you can write, can I write where c is equal to what? 0, 1, 2, 3, and so on. Correct? Huh. You got this point.
Yes,
Now,
sir.
now look at this. Now look at this. I was giving you different constant here, 9, here something called 0. Look at this, something called 0 here, right? Here I'm giving you 2, here I'm giving you some c. I'm giving you different constant, but the answer is same or not? Isn't it? But the answer is same, check everywhere. Isn't it? The answer is same, isn't it? But am I right? Yes. So I'll talk about here. Are you here, Adesha? Adesha, are you here?
Yes, sir.
Yes. So constant of integration. Constant of integration. What is this concept? Look at this here. For suppose I told you, right, everywhere 2x, 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 2x I have. So if I integrate the answer called 2x with respect to the variable called x, what is my answer is going to be always x square plus, sir, integration of this is what? Simple, look at this. I'll just give you integration of 2x is what? X square. Just now I have seen here. Check. But where is that? You just told, right? You just told, right? What I told, if I integrate this, I must get this function. But you're getting only x square. Where that 9 goes now? Why you're not getting that 9? You understand my point, Adesha? Is it clear? See, integration of this function is x square only you are getting. But where this 9 goes? Understood?
Constant. Yes, sir.
That is the reason I would consider that as a constant. Constant means it could be 0, 1, 2, 3, any number. Getting my point?
Yes,
So,
sir.
simply I would write it as integral of 2x dx is x square, where c is what? Where c is what? Constant of integration. All right, any doubts? Any doubts?
No, sir.
Yeah. Now I'll just give you a couple of formulas. I'll just give you a couple of formulas which is related to integration. Then, first of all, let us compare differentiation and integration. I'll show it to you. Okay. I'll just show it to you. So look at this. I was giving you one question, right? What was that question? Integral of 1 into dx is equal to, I told you that x plus c, right? I told you that this is x plus c. Now, similarly, look at this here. If I differentiate this, beta, 1 second. I told you that if I differentiate this, I must get this, right? Isn't it? You understand my point? If I differentiate this, d by dx of x plus c is equal to what? 1 or not? Hello? Isn't it? Hello? Are you here?
Sir, your voice was breaking bit.
Now can you hear me?
It's clear now.
Now what I'm saying here is integral of 1 dx is x plus c, I told, right? What I am saying here is d by dx of this has to be 1. That is what I'm saying.
1.
How it is, sir? D by dx of x is, we know that 1. Now if I integrate this, I can have to get this. That is what I'm getting here. Check. Isn't it? You understood? Yeah. Now look at this. So as I told you, beta, just now I gave you one formula. What was that formula? Integral of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. Right? Okay, sir. This was a formula plus c we were writing. Right? Now, if I differentiate, of course, where n should not be equal to -1, common sense. If I differentiate x to the power of n plus 1. N plus 1 is what? Constant anyway. Okay, n plus 1. N plus 1. What do you get now? N plus 1 into
N
n
plus
into
1.
x to the power of
N plus 1. n plus 1 minus 1.
So n, simple n, right? N plus
Yes, sir.
1 minus 1. 1 get cancelled. You simply get it was 1 here. All right, x to the power of n. All right. So I got this. Now, okay, this is what I got. But basically, look at this. Now what we need here, d by dx of this x to the power of n plus 1 by n plus 1. See here, but we need to find out d by dx of x to the power of x to the power of n plus 1 by n plus 1, right? But divided by n plus 1 or not as it is. You understand my point? Here, if you don't understand like this, I'll tell you. We need to find out d by dx of x to the power of n plus 1 by n plus 1, right? N plus 1 is a constant. I'll just throw it outside. Now d by dx of what? X to the power of n plus 1, which is 1 by n plus 1. As it is, d by x to the power of n plus 1 is what? N plus 1 into x to the power of n. This will get cancelled. X to the power of n is the answer or not? Again, I'm saying same thing I'm getting or not? Check.
Yes, sir.
Yeah. So that is a basic formula of integration. Right. So now tell me, look at it here. Example. Let's talk about an example. D by dx of x, integral of x to the power of 5 dx is what? Adding one power, in the numerator, x to the power of 6 by 6 plus c is the answer. Isn't it? Is it clear? Whatever the power you have,
Yes,
the
sir.
same number would be in the denominator as well. All right. So very simple, right? Yes. Now let me talk. These all are formulas. Please, no, I started writing the formulas. Now you also start writing the formulas. Now integral of 1 by x dx is what? See, d by dx of log x is 1 by x. So integral of 1 by x is going to be log x, ln x
Log x.
plus c. So how it is? Look at this. I'll tell you. But a d by dx of this guy is this one. Then integral of this guy is this, right? Isn't it?
So means we can say reverse of log is ln.
Look at this here. Not reverse of log. But look at this here. Log, ln, both are different. Okay. I'll tell you what is that. If log with the base 10 x, this is my common log. Okay, common logarithmic. Ln x with the base e, this is my natural log. Natural log. Basically, you write this as ln x. Ln x. Ln x is nothing but natural log. Log x to the base 10 is common log. Right? This also can be written as log x with a base e. If I have base as e, that is natural log. If I have base 10, that is common log. Common log generally would be used in science subject like chemistry and physics, right? But this ln x is the right. This ln x also would be used in basically in science and subjects like chemistry and physics. Now this is my natural log. Why we got this natural name actually? Because in the nature ln x first came actually. In the nature, in mathematics nature, ln x has been arrived first, then log x base 10. This has been arrived later than ln x. So ln x has been arrived in a mathematics family first. So we call that as a natural. Common log is nothing but base 10. Wherever you have base 10, that is common log. Hope you got an idea. Both are not same. Okay. Simply look at, let me
Yes,
write
sir.
here. Let me write here. This is log x. Simply log x. Simply log x is the base e. That is why you write ln x. Log x. This can be written as simply log x with the base e also correct. You understand? Need not write base e. See that e is hidden there. So you simply write it as log x. Okay. Log x or log. Simply look at this here. Let me write ln mod x plus c only, or log mod x base c plus c. Okay. See here, whatever the why we are taking modulus? Can you tell me there? Why we are taking modulus? Can you tell me, beta?
So maybe the value is either positive or negative.
No, not either positive or negative, because the domain, which means domain is nothing but the value of x, the possible values of x which I substitute in place of that position. So what are the values I can substitute in place of this green circle, in place of that x? Only positive values. It never takes what? Negative. Log, look at this beta. Log, inside log, never negative numbers not allowed actually. Okay. Here, log of something cannot be negative here, and base also cannot be negative. That is a property. That is the basic definition of the log. Okay. So that is why I'm keeping modulus x. Why? Because modulus makes always positive any number, isn't it? Isn't it?
Yes, sir.
I'll tell you one more time. Look at this here. Log x base c plus c. Huh. Modulus is nothing but beta. Modulus makes everyone positive actually. It makes everyone positive, right? Sir, why we are making unnecessarily positive there? Why? Because in place, base in next to the log, this never should, this should be always positive. This should be what? Always positive. Is it clear? It should be always positive. It cannot
Yes,
be
sir.
negative. So to make it as positive, we are always keeping what? Negative. For modulus x. Hope you are getting my point. Now let me erase this. I think we already done with this. Huh. Now look at this here. Look at this here. D by dx of that log x has to be what now? D by x of log x is what? 1 by x. Now if I differentiate this, you have to get that. Right? Am I getting or not? Yes. Next formula. Next formula. Integral of exponential e power of x into dx is same as like as differentiation only. E power of x plus c only. Now in d by dx of e power of x is what? E power of x only. Is it clear? Is it clear?
Yes, sir.
Integral of a power of x is what? A power of x by log a plus c. But d by dx of a power of x is what? A power of x into log a. Here multiplication, here division. Getting my point? The formula here e power of x, same formula for both the things, but here by log a, here into log a. D by dx of log a power of x is what? A power of x into log a, but in integration we get by log a. Here again, what are the rules for this? Here a has to be greater than 0 beta. A has to be greater than 0 and a should not be equal to 1. Why? Tell me. If a is 1, log 1 is going to be 0. That is why a should not be equal to 1 here. Getting my point? You understood?
Yes, sir.
Yeah. So these are the basic, thing I got. So you do one thing better. You just revise one more differentiation formulas and come to the class. So that it will be helpful to you. So if I teach more and more, you won't be understanding. You make sure that revise the differentiation formulas and come. It would be helpful for you. Okay. In the next class, we will be discussing
Yes, sir.
remaining formulas and basic questions of integration. We'll discuss it. Okay, all the classes you just try to listen, neatly and cleanly and start applying. You'll do really better in that. Okay, beta. Okay, let's make a move now. Thank you.
Yes, sir.
Next time onwards, like I already informed that every time it will be in the voice app only. Okay, thank you.
Sir, no, sir. It was showing that you didn't start the class. That's why.
No. I started, but I don't know what happened, what went wrong, but I had to restart it. Okay. But next time, like, yeah, I might have started some other class. I don't know what happened, but let me check. But every time you have to be in voice app only now. Why? Because if that in that topper OS, no, it is coming 40 minutes and I have to restart the meeting again. So two sessions, are being doing over there. So in voice app, like, it continuously we can take 1 hour class. It's not like in OS. In topper OS, what happens, you have to take 40 minutes again, the meeting will be ended up. You have to restart the meeting again, take one more session. It is on like, time wasting process. So that's why I just want to take on voice app only, so that there would be there would not be any kind of unnecessary disturbances. That is the reason. Okay. So always you have to join through
Yes,
voice
sir.
app. Okay. Thank you.